In today's class, we are going to discuss about matrices. This particular chapter, matrices and determinants, this is one of the scoring chapter as far as your JEE Advanced and Mains are concerned. But here, there are certain things that we must remember to solve the problem quickly. Because from the very beginning, my main motto is to reduce the problem solving time to a large extent. Particularly in this chapter, if you really want to reduce your problem solving time, there are certain matrices that you must remember so that we can get rid of some major calculations involving those matrices. So you will understand as the class progresses that what actually I want to tell you. So let's start our class. Here I have shown you two matrices. This is one matrix and this is another form. You must remember these two forms. This is the diagonal elements of this matrix and these two are non-diagonal elements. Now, in the diagonal elements, it is 1 and 1. In both the matrices, it is 1 and 1. And in the non-diagonal matrix, in the elements, 1 will be 0. As I have written here, here it is 0. And here any scalar p is there. In this case also 0 is here and the scalar is here. So now if I ask you to find out a to the power n, that is, you have to multiply the matrices for n times. Here you can save a lot of time if you can remember that whenever this kind of matrix is given and we have been said to find out a to the power n, simply you multiply n with that element which is opposite to 0. Here it was p. So I have simply multiplied n with that p. In this case, in the second form, p is here. So I have multiplied n with that p. That's it. It will save a lot of time. Okay. Now let us see matrix 2. Very, very important matrix. Here it is cos alpha, cos alpha. Every time this will be cos alpha. And non-diagonal elements will be one is sine alpha, another one is minus of sine alpha. In this case, you see minus of sine alpha is here for the first matrix and minus of sine alpha is here in case of second matrix. But in both the matrices, your diagonal elements are always cos alpha. In this case, if I ask you to find out a to the power n, that is you multiply this matrix for n times. This n is any natural number. Then this n is actually multiplied with the angle of all these trigonometric ratios. So here it will be cos n alpha, sin n alpha, sin n alpha. Similarly, for the second matrix, it will be cos n alpha, sin n alpha, minus sin n alpha, cos n alpha. That is, your n is multiplied with the angle. That's it. And one more interesting part for this matrix is that here A into A transpose is always equals to I. A lot of problems came in JEE Main based on this matrix. Okay. So now let me take one example to understand the fact more clearly. See this question. The question is A is this matrix which is given to us and P is another matrix given this. Now we have been said that your Q is PA transpose. And we have to find out the value of P transpose Q to the power 2021 P. Right? So I want to find out this matrix. So I can see that in the middle, we are having Q to the power 2021. So first, I have to find out that. So what is your Q to the power square? Let me just check it. PAPT into PAPT. So now it will give us PAPTPAPT. Now, those who don't know this form, he will go for multiplication of P transpose and P. And that is the recipe for disaster. A lot of time will be consumed. Have you seen the elements that are given? Root over of 2 by 7, root over of minus 5 by 7, and all these things. So if you go for multiplication, it will create a lot of problem. But one who has understood the form properly, he will straight away identify, sir, root over of 2 by 7, if I treat this thing as my cos alpha, so in that case, this is alpha, so this will be root 2 and this will be root 7. So the hypotenuse will be root 5. So clearly we can see that your sine alpha is root 5 over 7. The moment he do that, he has recognized the matrix given to us. And the moment he recognizes the matrix, he will say, sir, your P is basically cos alpha minus sine alpha, cos alpha. That's it. That's it. The moment he recognizes this, the sum is 80% over. We know that when P is this, your P transpose is nothing but your identity matrix I. So in this case, straight away I will write PAI-APT. So it will be actually PAI is basically A, so it is A square PT. So I have now recognized the pattern. Q square is coming to PA square PT. If you go for Q cube, it will give us A cube PT. So obviously, Q to the power 2021 is PA to the power 2021 P transpose. Yes or no? See how quickly we have reached our destination the moment we have recognized the matrix. That's why this matrix, particularly these two matrices that I have shown you in my previous page, are so very important. Okay, so we got Q to the power 2021 is this one. Now we have to find out the value of PT Q to the power 2021P. So in place of Q to the power 2021, I can write PA 2021 P transpose P. Now if I open the bracket, it will be PTP 2021 PTP. Again, PPT is same as your PTP because they are commutative. And that is equals to your identity matrix. So that gives us IA 2021I. That gives us A to the power 2021. So the answer has reduced to A to the power 2021. Now I have to find out that, in which we have been given A, but again we have recognized the matrix. It is 1, 1, 0, 1. So A to the power 2021 will be nothing but matrix 1, 2, 0, 2, 1, 0, 1. That's it. And that's your answer. See how quickly we can solve this sum? Only by remembering these two matrices form. That's it. Okay. So now let's move for a new conception. Characteristic equation. What is characteristic equation? It states that every square matrix has its own characteristic equation. Suppose we have been given a matrix, say A, of order, let us say, n into n. So A is a square matrix. It has its own characteristic equation. And what is that characteristic equation? It is determinant of A minus lambda. I is the identity matrix. Lambda is a scalar which is equals to 0. This is the characteristic equation of any square matrix A of any order. Suppose if A is a matrix of order 2, it's a square one, so it is 2 into 2 matrix. Then the characteristic equation will be a quadratic equation in terms of lambda. If A is a 3 into 3 matrix, then the characteristic equation will be a cubic equation in lambda. Okay? And the values of lambda are what called your eigenvalues. Right? They are called eigenvalues. Now, suppose, let us say, for an example, that A is a matrix given to us, let us say 2, 3, 4, 5. Now, if I ask you to find out the characteristic equation of this matrix, what you will do? You will simply find out the determinant of A minus lambda I, which is equals to 0. That gives us determinant of 2 minus lambda, 3, 4, 5 minus lambda, which is equals to 0. And that implies if I expand the determinant, we are going to have, so let me open it, 10 minus 7 lambda plus lambda square minus 12 is 0. So it's coming like lambda square minus 7 lambda minus 2 is 0. Okay? This is called the characteristic equation of this matrix A. Now, it has two roots. They are lambda 1 and lambda 2. Now, these two values are called, as I told you, are called eigenvalues of that matrix. Okay, so now observe one thing. The sum of two roots, in this case, the sum of two roots, in this case, it's 7. And you observe carefully that your lambda 1 plus lambda 2 is coming to 7, which is nothing but the trace of matrix A. Moreover, the product of these two eigenvalues is minus 2. And if you find out the value of the determinant, we are getting minus 2. So what we have learned? We have learned that whenever a 2 into 2 square matrix is given to us, the characteristic equation, I have shown you the actual way of finding out the characteristic equation. Now we are going for a shortcut method to remember, and we can directly write the characteristic equation of a 2 into 2 matrix. What is that? It states that it will be lambda square minus, for a 2 into 2 matrix, trace of A, lambda plus det of A, that is determinant of A, which is equals to 0. That will be the characteristic equation of a 2 into 2 square matrix. Now the question comes, sir, let us say that A is a 3 into 3 matrix. So in that case, do we have any shortcut trick to find out the characteristic equation directly? My answer is yes, we have. We know that when it is a square matrix of order 3, you will get the characteristic equation of degree 3. So it will be a cubic equation, the characteristic equation. So in that case, you remember in this way that the characteristic equation will be lambda cube minus trace of A into lambda square plus something into lambda minus date of A. Exactly the same thing that we have done. The sum of the roots, the eigenvalues and product of the eigenvalues, it will give us the trace of the matrix and the determinant of that matrix respectively. But in case of cubic equation, what will be this term? That is the coefficient of lambda. It is what? It is basically product of two roots taken at a time. That is, this one is basically if the three roots of this equation are lambda 1, lambda 2 and lambda 3, then your coefficient of lambda will be lambda 1, lambda 2 plus lambda 2, lambda 3 plus lambda 3, lambda 1. So is there any shortcut of remembering this? You people can do it. Simply by writing the characteristic equation, you can find out. But the shortcut way is, it is nothing but the sum of all the minus of the diagonal elements. It is the sum of all the minus of the diagonal elements. That's it. You know how to find out the minor of any element of our determinant? So these are the sum of all the minors of the diagonal elements, and that will be the coefficient of lambda. That's it. Is it clear? Absolutely. So we must remember this as a formula for third order and for the second order matrix. Now, there are two important things that you must remember. That is, if a matrix A has its eigenvalues like lambda 1 and lambda 2. Suppose it is a 2 into 2 matrix. Even you can take it as n into n matrix, no problem. Okay, let us take n into n matrix. So we are having n eigenvalues of that characteristic equation. Now, the inverse of that matrix, the characteristic equation of that inverse of that matrix will be the eigenvalues, that is the root of that characteristic equation is 1 by lambda 1, 1 by lambda 2, 1 by lambda 3 and so on 1 by lambda n. So if the characteristic equation of a matrix A of nth order has the eigenvalues lambda 1, lambda 2, lambda 3, so on lambda n, then A inverse, the characteristic equation of A inverse will have the eigenvalues 1 by lambda 1, 1 by lambda 2, 1 by lambda 3 and so on till 1 by lambda n. Moreover, if A has the eigenvalues this one, lambda 1, lambda 2, lambda 3, lambda n, then A to the power n, the characteristic equation of A to the power n, the eigenvalues will be lambda 1 to the power n, lambda 2 to the power n, lambda 3 to the power n, and so on lambda n to the power n. These are the eigenvalues of the characteristic equation of the matrix A to the power n. Is it clear? So we must remember this. Very important. And one more theorem is there. It is Cayley-Hamilton Theorem. It states that every square matrix is going to satisfy its characteristic equation. That is, for the first example that we have taken, the characteristic equation for this matrix is this. So from Cayley-Hamilton method theorem, it states that this characteristic equation is going to satisfy its own, the matrix will satisfy this characteristic equation. That is, your a square minus 7a minus 2i, this will be equals to 0. Clear? So this is how we got this. This came from Cayley-Hamilton theorem. Right? So these two things we have to remember by heart. Now let me take some examples based on this. See this question. A is a 2 into 2 matrix. Trace is given and the determinant is given. Now the question is, find out trace of A inverse. We know that the characteristic equation of the matrix A will be lambda square minus 5 lambda plus 3 equals to 0. Why it is so? Because we know the formula lambda square minus trace of A into lambda plus det of A equals to 0 is the characteristic equation of any matrix of order 2. So the characteristic equation of the matrix A is this. Therefore, it has two eigenvalues, the roots, which are lambda 1 and lambda 2. So lambda 1 plus lambda 2 gives us what? 5. And lambda 1, lambda 2 gives us what? 3. Now they have said, what is the trace of A inverse? What is the trace of A inverse? Can you tell me what will be the equation of the characteristic equation of the matrix A inverse? It is lambda square minus 1 by lambda 1 plus 1 by lambda 2 into lambda plus 1 by lambda 1 into lambda 2 equals to 0. Am I correct? Why? Because we know that if the matrix A has eigenvalues lambda 1 and lambda 2, then A inverse has the eigenvalue 1 by lambda 1 and 1 by lambda 2. So what will be the trace of A inverse? It is 1 by lambda 1 plus 1 by lambda 2, because this is the trace of the matrix. And in our case, the matrix is A inverse, because 1 by lambda 1, 1 by lambda 2 are the eigenvalues of A inverse. So we can easily find out what is the value of this. This is basically lambda 1, lambda 2, lambda 1 plus lambda 2. Now we have been given lambda 1 plus lambda 2 is 5 and lambda 1, lambda 2 is 3. Therefore, the trace of the matrix A inverse is 5 over 3. As simple as that. Have you understood? Let me take some another problem. See this question. This question came in IIT JEE 2005. In this question, we have been given that A is a matrix. And we have given a relation this, A inverse is this one. Straightforward question, find out the value of alpha and beta. Now, one who don't know the characteristic equation, he will face problem. Why? Because here he has to find out A inverse, he has to find out A square, and then he will write A inverse in one side and all other things in the right hand side. Then he will add it and then he will compare to get the value of alpha and beta. Hectic work. And it will take a long time to solve this sum. But one who knows the characteristic equation, this problem can be solved within a minute. See, your A matrix is given, which is actually a square matrix of order 3. Therefore, its characteristic equation will be lambda cube minus trace of A lambda square plus the sum of the minors of the diagonal elements into lambda minus det of A equals to 0. That's it. So, lambda cube minus, what is trace of A? It is 4, 5 and 1, that is 6. So, it is 6 lambda square plus. Now, what is the minor of this element? It is 4 plus 2, that gives us 6. What is the minor of this element? It will be, you cancel this row, you cancel this one. So, we are having actually 4. And what about the minor of this element? It will be 1. So this is 11 lambda minus determinant. The determinant will give us 6. This is equals to 0. Now from the Cayley-Hamilton method, theorem. It states that every square matrix satisfies its own characteristic equation. Therefore, a cube minus 6a square plus 11a minus 6 is 0. 6i equals to 0. Okay, so we can write your 6i is a cube minus 6a square plus 11a. Now, if I pre-multiply with A inverse, we are going to have A inverse A square minus 6A inverse A plus 11 A inverse A, right? So from here we are getting 6A inverse is, because we all know that A inverse A is same as your A inverse is always the identity matrix. So it is IA square gives us only A square, 6IA gives us only A, and 11I. So from here we are having A inverse is 1 over 6, A square minus 6A plus 11I. That's it. The sum is over. The moment we get this, now we will simply compare this with the given condition. So we get your alpha is minus 6 and beta is 11. That's it. That's your answer. See how quickly we can solve this if we know the characteristic equation. I hope this whole thing that I taught you today is very, very clear to all of you. Okay? Now, let us see this question again. This came in JEE Advanced 2020. It has been said that A is a 2 into 2 matrix such that trace A is 3 and trace A cube is minus 18. Now we have to find out what is det A. Simple thing. Absolutely simple. Because we know that for our 2 into 2 matrix, its characteristic equation becomes lambda square minus trace of A lambda plus det of A equals to 0. So it is lambda square minus trace of A is 3. So it's 3 lambda plus, let us say, det of A be t. Okay. So this is your t, which is equals to 0. Now, this characteristic equation has two eigenvalues. Let us say lambda 1 and lambda 2. Therefore, your lambda 1 plus lambda 2 is basically 3. And lambda 1, lambda 2 is t, which is actually your det A. Right? Okay. So our task is to find out t only. Now, we have been said that trace of A cube is minus 18. Now, what is the eigenvalues of the matrix A cube? If A has the eigenvalue lambda 1 and lambda 2, your A cube will have the eigenvalues lambda 1 cube and lambda 2 cube. Yes or no? Therefore, what is trace of A cube? It is basically lambda 1 cube plus lambda 2 cube. That's it. Which is actually lambda 1 plus lambda 2 whole cube minus 3 lambda 1 lambda 2 into lambda 1 plus lambda 2. Lambda 1 plus lambda 2 is 3, so it gives us 27. Minus 3 lambda 1 lambda 2 is basically your t, and this is again 3. So it gives us 27 minus 9t. Now they have already given that this is equals to minus 18. Therefore, 9t becomes 27 plus 18. So t becomes 3 plus 2, that is 5. That is det of A. That's it. Finished. That's your answer. That's your answer. Have you understood this? Here, lambda 1, lambda 2 are the two eigenvalues of the matrix A. the roots of the characteristic equation of the matrix A. Therefore, the eigenvalues of the characteristic equation of A cube will be lambda 1 cube and lambda 2 cube. And what is the trace of A cube? It will be the sum of the eigenvalues, which are lambda 1 cube plus lambda 2 cube. And from there, we got the value of date A. Is it clear? See, this sum came in JEE Advanced 2020. If you only know the basics, you can solve this problem, right? So let me give you one problem for your homework. This sum is your homework. What is the question? A is given, B is given another relation, A is in between. The question is, find the sum of all the elements of this matrix. Find the sum of all the elements of this matrix. So try to think on that and write the answer in the comment box. I hope you have enjoyed this class. See you tomorrow. Until then, take a very good care of yourself. Thank you so much.